So today's lesson is going to be on Lewis structures. And we're going to start with our worksheet that is on the website, Lewis structures for ionic compounds. And we're going to look at our first example of hydrogen. Now, let's start by drawing the Bohr model for hydrogen. And what do we know about hydrogen? Hydrogen has one proton. Let me focus that in better. All right, hydrogen has one proton and it has no neutrons. And in its neutral form, it also has one electron. So I've color-coded this because when we draw a Lewis structure, we are going to write the symbol from the periodic table. So for hydrogen, that would be an H. And we add in the valence electrons only. So this hydrogen represents the nucleus and any core electrons. The valence electrons go on the outside. So let's look at our second example, Al. That has 3 valence electrons, so 3 dots. And remember, here we are. Aluminum is in group 3A. It has 3 valence electrons. Now, we're going to skip down to the draw the Lewis structures for the ions. So let's start with our first example of an ion. And we're going to start with phosphorus, all right? Now, phosphorus is in group 5A. It has 5 valence electrons. So I'm going to start by drawing phosphorus in its neutral form. Now, to create an ion, phosphorus is either going to lose 5 or gain 3. Remember, we always choose the smaller option. 3 is smaller than 5, so gain 3. So when phosphorus gains 3 electrons, it becomes a negative. And how many electrons did it gain? 3. 3 minus. All right, let's look at our second example, calcium. Calcium has 2 valence electrons. So when I start in my neutral form, there's my 2 valence electrons. Now calcium. Is it going to lose 2 or gain 6? Again, we choose the smaller number. 2 is smaller than 6. So I'm going to lose 2. So when calcium loses 2 electrons, and I'm going to erase those as best as I can. See if I can't erase that a little better. There we go. So when calcium loses 2 electrons, it no longer has any dots. It lost 2, making it a positive, Ca2+. So you will notice your cations have no dots because they have lost those electrons. Your anions have 8 dots because they've gained electrons. They are both in brackets with their charge. All right, so let's look at the very last piece of this worksheet, and let's draw some Lewis structures for ionic compounds. So let's start with our first example, lithium chloride. So we're going to draw the Lewis structure for lithium and chlorine in its neutral form. So notice we keep working here, and we've always been working on these in terms of their neutral to begin with. Lithium has 1 valence electron, whereas chlorine has 7. So I have 1 dot for the lithium and 7 dots for the chlorine. So what happens? Lithium donates the electron to the chlorine. So lithium is a positive, and chlorine now has 8, and it is a negative. So there we go. Now we have our attraction between our positive cation and our negative anion. All right, let's look at our next one, MgBr2. In math, if there is no number behind or in front of it, is understood to be a value of 1. So there is no number behind the magnesium, so this is understood to be 1 magnesium. How many bromides do I have? I have 2 bromides. So I'm going to draw magnesium, which has 2 valence electrons. And I have 2 bromines, so Br and Br, going to draw both of those. And bromine has 7 valence electrons, so I'm going to put in 7 valence electrons for each bromine. Now, if you are unsure of how I'm finding these valence electrons, you should go back and watch my video on valence electrons. Now, what's going to happen? Magnesium is going to donate 1 electron to each bromine. It does not matter. Honestly, we could have taken this top electron over to the second and this side electron to the first bromine. It really, truthfully, does not matter. What you need to show is there is a transfer of electrons to fulfill bromine's octet. Magnesium loses 2, making it a 2+. Now, each bromine becomes 7 plus 1 is 8. So it becomes the ion bromide, which is a negative charge. And what do we know about negative and positive charges? We know that a negative and a positive attract. What if I put another Br minus side by side? Because I technically have 2 bromines. What do we know about opposite charges? Opposite charges attract, and like recharges repel. So these 2 Brs are going to repel. So we can't draw the bromine beside the other bromine. We have to draw it somewhere, whether we put it on top, to the side, or down at the bottom. We need to show an attraction between a positive and a negative. So I'm just going to put my bromine to the left here. And there we have it. This is MgBr2.